welcome to Unit 9.4. Okay, today we're going to talk about linear, quadratic, and exponential models. So we've already watched that video, okay, about the three islands, okay, and kind of started to get this idea of having different representations. Okay, so we have those linear models, and they have something called a common difference. Okay, so that common difference, that's a vocab word we're going to want to include in our notes. Okay, and the common difference comes from subtracting consecutive y values. So remember, consecutive are one after another. Okay, then we have quadratic models. Okay, and they have a constant second difference. So the second difference means we subtract the y values twice. Okay, so we subtract them a first time, just like we do with linear, and then we're going to subtract them again, okay, subtract the differences then from each other. Okay, and we'll see all of this in action in just a few minutes. Okay, and lastly we have exponential. They have something called a common ratio. Okay, so the common ratio comes from dividing consecutive y values. All right, so we're either going to be subtracting them or we're going to be dividing them. Now, those actual values that we find, they're going to be useful then in writing the equation or writing how what models the values in the table for us. Okay, so a linear function we know is y equals mx plus b. So we need to find the m and the b, the slope and the y-intercept. Well, lucky for us, the common difference is going to be representing the slope. Okay, and then we'll talk about, when we do an example, we'll talk about ways to get the b. Okay. In an exponential, we're using the form y equals a times b to the x, okay, which means we need an a and a b. Okay, again, the b is going to be represented by the common ratio, so that value that we're going to be finding anyway, in order to help us classify, we're going to use that in the equation. Okay, and then we're going to talk about how to find the a value. And last but not least, we have the quadratic. Now the quadratic is going to end up being a little bit more complicated than the others, okay? The common second difference does not actually get used in the equation, okay? We're going to end up making a system of equations, okay? If you remember that from Unit 5, we're going to make a system of equations and either use substitution or elimination to solve. Okay, so let's look at an example for each one. All right, so first we want to determine, is this table linear, quadratic, or exponential? So you want to start with either dividing the values or subtracting them, okay? And we actually start from the back or the bottom. We start from the end, and we go backwards, okay? So we actually are doing 484 minus 425. Okay, 425 minus 366, and so on. Okay, but if we start from the back and kind of go in a reverse order, we make sure that we're doing the subtraction correctly, because remember, in subtraction, order matters. Okay, so we go here to here, here to here, and so on. Okay, so if we subtract all of these, you'll find that each one of these has the same difference of 59. Okay, so that makes this the common difference. And so this is a linear example, or a linear model. Okay, so we're going to use y equals mx plus b, and we're going to write the equation that's modeled in the table here. okay, which means we need m and b. All right, we already have the m. That comes from the common difference. And we're going to find the b by working backwards. So we're going to take this very first value in the table, okay? The b happens at 0. So we're going to walk 248 backwards using our common difference, and we're going to find our b value is 189, okay? And then you could test that. You could say 248 minus 189 and make sure that you get that common difference, okay? So our final answer here, 59x plus 189, okay? And you could plug in any of those ordered pairs from the table into that equation to check that it is true. Okay, but that's our linear model for this table. Okay, to get that b value, you could also take any one of these ordered pairs from the table and plug them in for x and y and solve the equation for b, just like we did way back in Unit 3. Okay, that's also an option. I'm just trying to save you a little bit of work here. Okay, example 2 now. Okay. Well, we've already tried the subtraction. Let's try and divide the values. Okay, so again, I'm going to start from the bottom up so that I do the division in the correct order. Okay, so I would do 5,150.72 divided by 6438.4. Okay, and I highly suggest that you write out these problems, okay? These little subtraction and division problems. I mean, they take what, 2 minutes to write this out, okay? But I think it's really important. And when you solve each one of these, so plug each one into your calculator, okay, you'll see that this actually works out and they all come out with the same answer of 0.8. Okay, well, doing division, that means this is my common ratio. Now, you might have to try and subtract everything once, subtract everything twice, and then divide before you find your common value. Okay, so if it's a common ratio and I've done division, well, that means that this is exponential. And we're using y equals a times b to the x. Okay, so our notes at the beginning of the video here told me that the common ratio is my b value. Okay, so I need an a and a b in order to write the equation here. So the b is my common ratio that I just solved for, 0.8, and the a value is going to happen when x equals 0. Okay, remember that from earlier in this unit, the initial value, the a value, is at time 0. So you want to look to your chart and see, well, do you have time 0? Which we do. If we did not, if this table started at 1, we could do just like what we did in example 1, where we worked backwards, and we would take that value that we were given, okay, and we would do the opposite. We would multiply by our common ratio, and we could get to that initial value. So that's given to us. T equals 0 is given here, so my initial value is 12,575. Okay, so I have my a and my b. I'm going to plug them in to my equation. Okay, again, you could use skills that we did in 9.3 3 in those word problems, because this is technically like a non-rate equation. Okay, and since you have an a and a b value, you could use those, or I'm sorry, since you have a b value and then you could choose any xy from the table, could make this x, could make this y, you could solve for a. Okay, again, I'm just trying to use the table and the values that we have to save us some work. Okay, to just work backwards from what's there rather than having to solve fresh. All right, so our last example here, okay, by process of elimination, this is going to be quadratic. Okay, I want you to take a deep breath because this is going to take some extra work, okay? So we have to make a system of equations here. All right, so first thing we're going to do is prove and identify that it actually is quadratic. Okay, so quadratic uses a common second difference. So we're going to subtract. Okay, we're going to do subtraction once like we did in example 1 with linear. Okay, we're going to start from the bottom. We're going to go backwards. So 24 minus 14, 14 minus 6, 0 minus negative 4. Be careful with that last one. Okay. So each one of these is going to give us a different answer. All right, do not get discouraged. Don't think that we did it incorrectly, because this means we just have to subtract again. Okay, so we're going to do each of these from each other now. Okay, so 10 minus 8, 8 minus 6, 6 minus 4. Okay, and these you want to pair up the way that they're written, just how I did here. Okay, and you see that we get the same difference. Okay, 2, 2, and 2, the same second difference. So that makes this quadratic. Okay, and that's y equals ax squared plus bx plus c. All right, so we have to make a system. Okay, before that we have to identify some other things that are in the equation. So the first thing to know, okay, is that this ordered pair that has x value of 0, okay, when x equals 0, that's the c value in our equation right here. That's going to be the c value, whatever goes with 0. So that means, in this case, that c equals negative 4. Okay, so that's step 1. Okay, so now step 2, on our way to creating this system, we're going to choose any 2 points from this table. Okay, I'm going to take 2, 6 and 3, 14. Okay, and I'm going to use these as an xy value, and I'm going to plug them into 2 separate quadratics. So watch, these are each x and y. Okay, and combining that with the fact that c equals negative 4. So anywhere that I see a y, I'm going to plug in each y value from the ordered pair, and then the same thing with x, and both of them are going to get a c value of negative 4. Okay, so watch how I set these up. All right, so these are the start of my system. So I'm going to take this with me. I got to go to the next slide to give myself some room to work. Okay, so I'm just going to rewrite exactly what we just had. So using any ordered pair, plug it in for x and y, and plug in our c value that we get from the ordered pair of 0, comma, a number. Okay, so I'm going to simplify these. I'm going to clean them up, do those like 2 squares, 3 squared. All right, I'm going to do a little bit more solving here. Okay, because this -4 on the end of each equation, I could move to the left side because I have a number on the left in each one. Okay, so I'm going to add 4 to both of these, okay? I'm trying to do a little bit of solving. I'm moving them to the other side. So I have 10 equals 4a plus 2b, and now 18 equals 9a plus 3b. Okay, so let's just pause for a minute and revisit how we got here. Okay, so we found our c value because that comes from the ordered pair matched with x equals 0. Okay, and that has to be given to you in the table. We then picked any 2 ordered pairs and we set them for x and y in a quadratic equation. We did that twice because they were 2 ordered pairs. So we plugged in for x and y. Okay, and now over here, we did some simplifying. So we squared those. And then we moved c to the other side. Okay, and that's how we ended up with these 2 equations. And we now want to do substitution or elimination on them. And we want to solve for a and b. Okay, so I think that elimination is probably our easiest option here. Okay, since I don't have, a coefficient of 1 in order to substitute. Okay, so I'm just going to rewrite again over here so it's clean and I can solve. All right, so I'm trying to get one of my variable to have the same coefficient so they cancel. Okay, I'm going to have to multiply. I'm going to multiply the top by 3. And I'm going to multiply the bottom by 2. And I'm going to use -3 on the top so that the signs become opposite. Okay, so I'm multiplying that all the way through. And then a 2 to the second equation. And we see by doing that, I end up with a -6b and a +6b. So you could have gone for the A, and you still would have gotten the same answer. Okay, you would have just multiplied by something differently. So when I add my 2 equations together, those will cancel. I'll get 6a equals 6. Okay, so we have a equals 1, but remember we also need the b value. So I'll take a equals 1 and plug it back into an equation. Okay, so now we have the A and the B, and we had previously found the C. So we'll just take those values and plug them back in to ax squared plus bx plus c here to get a final equation. Okay, so quadratic, definitely the more challenging of the three. Okay, definitely the most work of the three examples. And we have to remember how to do that substitution and elimination. All right, so just for right now, make sure that your notes are complete. I do encourage you to maybe rewind a little bit and rewatch this quadratic example, maybe one more time, where you're not taking notes at the same time. All right, but otherwise, make sure that all of this is complete. Write down any questions that you have, okay, and we will go over them the next time that we're together. Thanks so much for watching, guys.